Hello bachcho. So today we are discussing the JEE Mains paper series. So today we are discussing 22 January of 2026 shift 1 JEE Mains 2026 physics first shift paper. Okay. So we can discuss one by one each and every question. So we are solving one by one each and every question. So first question. So the volume of an ideal gas increasing by 8 times. Okay. And temperature becomes it's 1/4 of the its initial temperature. During the reversible change, if there is no exchange of the heat in the process, means my delta Q equals to 0 here. So the identify the gas of the following options. Assume the gas given the options are ideal gases. So beta delta Q equals to 0 means what is the my process? Process is the my adiabatic process. Okay, adiabatic process means my delta U equals to del W. Okay, so delta U equals to del W, and in adiabatic process what is the my del W? Del W equals to PV power gamma equals to constant, and if we are further this one we convert this one, so T into V power gamma minus 1 equals to constant. Okay beta, so what we can do here, just we can take its initial temperature, I will consider T, and after this one it temperature T1 and T2 I will just considering. So T1 by T2 equals to V2 upon V1. Okay beta, gamma minus 1. So initial temperature I will just consider T, and the temperature T2 is 1/4 of the its initial temperature. So what is the my T1? T1 I am just considering T. So T upon 1/4 of initial, so T by 4. Okay, equals to its second volume is 8 time of its initial volume. So 8 divided by its 8V divided by V power gamma minus 1. Gamma minus 1. Okay beta, so what we can do, T to T is cancel out, 4 is going up, so 4 and 4 equals to 8 power gamma minus 1. So 2 power 2 equals to 2 power 3 gamma minus 1. Okay, so just you can compare 2 equals to 3 into gamma minus 1. So 3 is 2 by 3 equals to gamma minus 1. So my gamma equals to 1 plus 2 by 3. So all of you know what is the my gamma? Gamma equals to 1 plus 2 upon F. So F is the my degree of freedom. So just both you can compare here, this one and this one. So F equals to, you can get 3. So what is the my 3? 3 is the degree of freedom. So 3 is degree of freedom for the my monoatomic gas. So just you can see which one is the my monoatomic. So only helium is here my monoatomic gas. Okay, so what is the my final answer for this one? That is the my helium. Okay beta, next question what they will tell. Okay, so the option second. So the solid sphere of mass 5 kilogram and radius is 10 centimeter is kept in contact with another solid sphere of the mass 10 kilogram and radius is 20 centimeter. So the momentum of inertia of this pair of the spheres about the tangent passing through the point. So what is the my momentum of inertia going through its tangent? That is 7 by m into r square. So both are contact. So total momentum inertia I1 plus I2, because both they have different mass and different radius. So just you can 7 by 5 I will take common out, m1 r1 square plus m2 r2 square. Okay, there is square better. So just you can put the value of first one, mass is 5. Okay, I am just putting here 5, 7 by 5, m1 is 5 into first radius is 10, 10 into 10 to the power minus 2 whole square plus 7 by 5 into second mass is 10 kilogram, 10 into 20 into 10 to the power minus 2 whole square. So just you can solve both these things, so you can easily get what is the my answer. So this one you can calculate, that time you can get 7, 5 to 5 is cancel out, and this value you can get 0.0 7. Second one, 2 times this will be cancel out, and 1 is also cancel out here. 0.2 square 0.04, and 7 into this one, so this value you can get 0.56. okay, so 0.56 is the just you can you can add, so you can get total momentum of inertia. The total momentum of inertia you can get 0.63 kilogram square into meter square. So which option? Option third is your correct answer beta here. Okay, just you can find what is the momentum of inertia according its about its tangent. So that is 7/5 mr square, both are contact. So just you can, for finding the total momentum of inertia, just you can I1 plus I2, and that formula you can use. So you easily can put the values and you can get answer. Okay, next question. A projectile is thrown upward at an angle of 60 with horizontal. The speed of the projectile is 20 meter per second when its direction of the motion is 45 degree with the horizontal. Okay beta. Its initial angle is 60 degree, and that time I will just consider its speed is u. Okay, at this point its angle with my horizontal, that is my 45 degree. So you can take the component of this one, and at that time its velocity is here is my 20 meter per second. So 20, so what is this component? Horizontal, 20 cos of theta, and this will be equals to my this horizontal component, its initial u cos 60 equals to 20 cos of 45. Okay, so u cos 60 value is 1/2 equals to 20 into cos 45 1/√2. So just you can multiply that side, so u equals to, you can get 20 into 2/√2. So this will be u equals to 20√2 is your final answer. Okay beta, so which option? U equals to 20√2 is the your final answer. Okay, just you can compare the horizontal component of the my projectile here. Okay, we will move for next one. Okay, next one. So given there are two statements. First one, pressure of a fluid is exert only on a solid surface in the contact, as the fluid pressure does not exist everywhere in the still fluid. No beta, this is the wrong, because all of now my Pascal's law. So if we are applying small force pressure, so it will be equally distributed everywhere. So my statement 1 is wrong. Okay, statement 2. So the excess potential energy of the molecule on the surface of a liquid when compared to the interior result in the surface tension. Okay beta, so if my this is the my container and it will be filled up to this one some liquid. If I will just consider there is the my one molecule, so there is the and one molecule is at the surface. So only surface this will be force only there. Okay, only due to these molecules are attract this one, but in complete inside this one there is the lot of force are working due to different molecules. There is the force is working, so those are cancel out to each other, because this one, suppose this one direction, so those are cancel out to each other. So that's why there is the more potential. Okay, so statement 2 is your right beta. So both statement 1 and statement 2 are true wrong. Statement 1 is true no, statement 1 is false, and statement 2 is true yes beta. Option third is your correct answer. This is completely beta theoretical based question. Okay, next one we will move. What is the my dimension formula of the correct dimension? So the first one is the spring constant, F equals to K into X. X is my length of the spring. Okay, so first F equals to K into X, M1 L1 T minus 2 equals to K into L1. So this will be cancel out. So M L0 T minus 2. So first one is with my second. Second is the thermal conductivity. So beta, what is the my formula of thermal conductivity? So the formula of thermal conductivity, K equals to QL upon A into delta T. K equals to Q divided by A delta T, so temperature difference, and its length is L. So Q is my heat. Heat equals to Q equals to heat per unit time, H into L divided by A into T is time, and delta T is my temperature. So heat M L to T minus 2, and L is length. So M1 L2 T minus 2 into L1 divided by area is L2, time is T1 and temperature is Kelvin. So just you can solve this one. So L2 to L2 is cancel out. So M1 L1 this one and T minus 3 and K minus 1. So second one with my fourth. Okay beta. Third one is the Boltzmann constant. So Boltzmann constant Kb into T equals to energy. Okay. So Kb equals to Boltzmann constant equals to energy per unit. This is my temperature. Okay beta. So M1 L2 T minus 2 divided by temperature. Okay, that is my Kelvin. So K minus 1. M1 L2 T minus 2, M1 L2 T minus 2, K minus 1. My Boltzmann constant is first and remaining is the inductive reactance, that is like to my resistance. So option third is your correct answer. We can match first one with my second. First one with second. So second option is wrong and fourth is wrong. Next one, second is matched with my fourth. So second is matched with fourth option. First one is your correct answer. Only you can identify two correct dimensions, then you can get the correct answer for this one. Okay beta. Next question. This is the important question beta. Rod X and Y of equal dimensions but of different material are joined as so in the figure. Okay. So the temperature of the endpoints A and F is maintained at the 100 degrees Celsius and 40 degrees. So this will be 100 and this will be my 40. Okay, respectively. Given the thermal conductivity of rod X is the 3 times of the thermal conductivity of my rod Y. Okay beta, means my Kx equals to 3 times of Ky, that is given. Rod Y. The temperature at junction point B and E. They will ask what is the temperature of junction point B and E close to. Okay, so just we can do the calculation for this one. So this question we can solve using the heat current. So beta, all of you know what is the my resistance of this one. R equals to L upon K into A. Okay, so K into A. So for according to this one, Rx equals to 3 times of Ry. So what is the my resistance of Ry? Because both are inversely proportional to, that is 3 times of Rx. If I will consider the resistance of that length of X bar, okay, X is the R. So Rx I will just consider R. So what is the my resistance of Ry? That is my 3R. Okay beta. So X you can replace by R, 3R, R and 3R. Okay beta. So I am just applying again KVL here and I will solve this one. So just I will make the complete diagram 100. Okay beta. So this is the my diagram, 3R and 3R, R and R, or this is R and this is my, there is also resistance 3R. So I am just applying KVL here. So for first I will apply complete this one. Okay. So because complete is this one, 100 minus 40 potential difference. So the current from this complete segment 100 minus 40 divided by R equivalent. So this 336 divided by 2 R. So this will be 6R, 2R and 3R and R. Okay beta. So this is my final diagram. So what is my total resistance? Both are in parallel and all three are in series. So what is this one? R plus 6 into 12 divided by 8. Okay, 3 times okay, 8. So 6 into 2 is 12 divided by 8 into R plus what is this one? That is 3R. So this is the complete current in my complete circuit, but I am applying what is this one only in this segment, that is my 100 equals to 100 minus its junction point theta B. I will just consider theta B, and what is this resistance of this one? That is my R. So this one you can just solve only just calculation. So theta B equals to, you can get 89 degrees Celsius. Similarly you can apply in again this one, because someone is asking, sir, how to write this one? Because just you can consider my total current is entering I here and it will be divided in two parts I. So for complete circuit this one is my current, and for this circuit, because in this circuit, how much current is flow? I. So this is the completely flow here, because I is divided into I1 and I2. So again at point E, both are mixing, so I1 plus I2. Similarly, you can apply for the junction E. Similarly, 100 minus 40 divided by R, plus this will be 336, okay, 3, okay, 336 and 6 into 2, 12 by 8R plus R equals to, this temperature I will just consider theta, E minus 40 divided by 3R. Okay, so this one you can solve, then you can get theta E equals to, because R is cancel out everywhere, and theta equals to, this one you can get theta equals to 73 degree Celsius. So option third is your correct answer beta here. Nothing is there, just you can use the heat current formula, heat current method, and you can apply KVL. Okay, so I hope all of you are understand this one up to this one. Next one, 79 mega electron volt alpha particle is scattered from the target metal of atomic number is 79. Okay, from the given data, the estimate diameter of the nuclei of the target metal. Okay beta, this is the my target metal 79, and it is the my alpha particle. So charge of this one is 2e, and its mass you can just consider, and they are at initially infinite distance. So just you can derive this one. Initially its potential and its initial kinetic energy is k, and it is at infinite, so my initial potential energy of this one is 0. So just you can apply energy conservation here. Okay, so initial 0 plus k, and it's finally it is coming rest, and it is the, what is the its potential energy, k and q1 q2 jd square. So just I will directly write here radius approach formula. Okay, r naught equals to 2 z e square upon 4 pi epsilon naught into its kinetic energy. So everything is given beta here. So just use that formula, put the values, and you can get answer. Okay, so 1 upon 4 pi epsilon naught value is 9 into 10 to the power 9. Okay, so I am just doing calculation here. 10 to the power 9 into 2 into z of this one is 79, and e is 1.6 whole square divided by its kinetic energy 7.9 into mega means 10 to the power 6, and electron is 1.6 into 10 to the power minus 19. Okay, so just do this calculation. This will be cancelled out with this one, and 10 to the power 6, okay, 79. So r naught equals to, you can get 2.88 into 10 to the power minus 14. So this is the my radius, but what they will ask are diameter. So how we can do, we can just multiply radius by 2. So diameter d equals to 2 into 2.88 into 10 to the power minus 14. So this value you can get d equals to diameter of this one, that is 5.76 into 10 to the power minus 14. So which option? Option third is your correct answer. Okay beta, nothing is there. Next question. A ammeter bridge of two resistance R1 and R2 as shown in the figure was balanced null point at 40 centimeter from the point P. This distance is my 40 centimeter. The null point changed by 50 centimeter from the point P. Okay, after some time its null point is changed at that is the at point P, and when, which time can change this one? When the 16 ohm resistor is connected to parallel with my R2. Okay, if I will connected one resistance of 16 ohm at this point, then its null point is changed by 50 centimeter from point P. Okay, so the value of resistance R1 and R2, nothing is there. R1 by R2, its first null point is 40 centimeter. 40, 100 minus 40, so this will be 60. So 4 by 6, 2 by 3. So R1 equals to 2 by 3 R2. Okay, first relation. When I will connect this 16 ohm this one, so what is the my resultant R2? R2 is replaced by so I will apply R1 divided by, both are in parallel, so 16 into 2 R2, sorry, not 2, divided by 16 plus R2 equals to 50 divided by 100 minus 50. So 50 is cancel out. Okay beta. So R1 equals to, you can get 16 R2 divided by 16 plus R2. Okay, and R1 equals to, you can put 2 by 3R. So I am just putting here R2 equals to 16 into R2 divided by 16 plus R2. R2 to R2 is cancel out, and this will be 8 times. Okay, so just you can solve this one. So easily you can get answer for this one. That is my 16 24. So R2 equals to, you can get, that is my 8 ohm, and 8 you can put here. Here, so 8 into 16 by 3. So my R1 is 16 by 3. Okay, so R1 is my 16 by 3, and R2 is my 8 ohm. So option B is your correct answer beta here. Okay, next one. So the escape velocity from the spherical planet A is 10 km per second. So the escape velocity from another planet B, whose density and radius are 10% of those the planet A is. Okay beta, nothing is there. What is the my escape velocity formula? All of you remember, V equals to root 2 gm upon R. On R, mass equals to density into volume, R cube into its density of rho divided by R. So here you can see my velocity of this one, V escape velocity is directly proportional to R into its density rho. Okay beta, so just you can take the ratio of my V1 by V2 equals to R1 square root of rho 1 divided by R2 square root of rho 2. So what is my initial the escape velocity from sphere? 10 km per hour. So the escape velocity of the another planet B, whose density of and radius are 10%. 10% means 0.1 of initial. Okay, so just you can put here beta my 0.1 of this one. Okay, so you can take R and its initial density rho 0.1 R into square root of 0.1 rho. So rho to rho is cancel out, and R to R is also cancel out. So V2 equals to, you can get V2 equals to V1 into 0.1 into root of 0.1. So this value you can get easily. V1 is my 10 into 10 to the power 3, because this is the in kilometer per second, but we need in meter per second, into 1 by 10, and square root of this one is 1 upon 10. Okay beta, 1 by 10. So this calculation you can do. So V2 equals to, you can get easily 10 to the power, this will be cancel out here, and this will be going. Okay, so this value 10. Okay, 100 into 10 into 1 by root 10. So this will be 100 into root 10. 100 root 10 means option second is your correct answer beta here. Okay, so we will move for the next question. Next question is 6 point charges are kept at 60 degrees apart from to each other on the circumference of a circular radius R as so in the figure beta. So the net electric field at the center of the circle. So beta, you can just see this arrangement. So there is the this angle is my 60 beta. Okay, but this angle is my 30, that is given in the question. Okay, so this is the plus charge and this is the plus charge, both are cancel out to each other. Similarly, you can see here this one and this one also cancel out, because both are, this will be repel this one, this will be repel this one, so both are cancel out. But this is the my negative charge and this is the my positive charge, so both are, due to both this one is in this direction, due to this one because it is attract, and this will be also this one. So I am just write directly E equals to 2 into kq upon its radius is R square. Okay, but both are at 30 degree angle. this is the my resultant, and 30 degree. So I will just take the component. So this is the my cos 30, and this is the my sin 30. Cos 30 value is root 3 by 2, and this is the 1 by 2. So just you can take the component a cap. Initially I will just consider this direction is a cap. So I am just putting the values of a cap. E vector equals to 2 into kq upon r square into cos theta is minus I cap. So root 3 by 2 minus I cap plus 1 by 2 j cap. So you can see easily here my 2 is cancel out here. Okay, so what is the my E vector? K q upon r square into root 3 minus I cap plus j cap. So you can take common out. So root 3 I cap minus j cap. So which option is matching here? Option 1. Okay, so the option 1 is your correct answer beta here. Next question. So three identical coils C1, C2, C3 are close pairs such that they share a common axis. Okay, common axis, not concentric. C2 is exactly midway. Okay, and C1 carries current in I in anti-clockwise direction, and C3 is carrying current I in clockwise direction. Okay beta, I am just taking here. Okay, so first one I C1, C2 is in midway, and this is my C1 and this is my C3. Okay, so C1 is carrying current in anti-clockwise direction, so the current in this one I. Second one is C3 is carrying current in clockwise direction I. Okay, so the induced current flow through the C2 will be in clockwise direction. So beta, you can see here Lenz's law. When it is tried to move here in the toward the my C2, this is the moving toward the my C2, so the flux through going through the in my C2 is increasing, so it is try to reduce it, so the current is in this one my going in the clockwise. Okay beta, when this C3 is move away, so again the flux through going through the my C2 is decreased, so it will be it will be increased. So according to the Lenz's law, so it will again clockwise. Okay beta, so which option? First one is moving toward the my C2 and it is going away from the my C2. So C1 move away from, no, C1 is moved towards C2 and C3 is moved away from C2. Yes, option second is your correct answer beta here. Okay, next question. So the minimum frequency of photon required to break a particle of mass 15.348 AMU into 4 alpha particle is in kilohertz. So the mass of the helium nucleus is this one. 1 AMU equals to how to we can convert into kilogram, and H equals to this one. So beta, this one be easy question, not that much tough. First we can find what is the mass of the breaking particle. Mass is this one, 8. So the 4 alpha particle, so what is the my total mass of 4 alpha particle? M2 I will just 4 into mass of helium nuclei, this one 4.002 AMU. So this will be, you can get 16 point, this will you can multiply 16 point approximate 16.008. Yes. So what is the my mass change in my mass? So delta M, that is 0.88. Okay beta, so 0.88 into AMU in this one. So we can try to convert this one into also my kilogram. So what we can do, we can multiply with 1 AMU equals to this one. So I directly write here in kilogram. So 1 into 10 to the power minus 27. So delta M value you can get here, that is my approximate 1.095 into 10 to the power how much, that is my approximate 27. Okay, this is the my change in delta M. So E equals to mc square. Okay beta, all of you now Einstein energy equation, C square. So delta M you know 1.095 into 10 to the power minus 27 into 3 into 10 to the power 8 whole square. So this energy you can get approximate 9.84 10 to the power minus 11. Okay, so energy required to photon E equals to H into F. Okay, H is my Planck constant, so F equals to 9.84 into 10 to the power minus 11 divided by my H is 6.6 into 10 to the power minus 34. 934. So this is my frequency you can get. Final frequency they will ask in kilohertz. Okay beta, so just you can do this one, so you can get 14.94. okay beta, and 14.94 into 10 to the power 20. okay, okay, just do the calculations. Option third is your correct answer beta here. Next one, X PYQ is a vertical smooth long loop having a total resistance R, where Px is parallel to the Qy and separation between them is I into I. okay, separation between them I. okay, L, this is the L, not I. A constant magnetic field perpendicular to the plane of this loop exists in the interior space. okay, so the rod CD is length, this is greater than this one. okay, and the mass M made to slide down for rest. okay, under the gravity as so in the figure. So the terminal speed required to by this one. okay beta, so nothing is there, just you can put the values. okay, my values of this one, how much downward direction my mg force is also working there. okay, so when it is moving down, so F equals to this force during this motion. So my EMF is also produced here, so E equals to BLV. So how much current flow in this circuit so current is I equals to V upon R, so I equals to BLV upon resistance of this one is my R. okay, so what they will ask when it is moving, so there is when current flow through the rod, so interior in this process, so my Lorentz force is also under the magnetic force, so the Lorentz also working. So FB, that is my F equals to F equals to BIV. okay, BIV, and terminal velocity means my mg and FB both are equal. okay, FB equals to my mg when its velocity is this one. So just you can put F equals to BIV and I current is this one. So B square L into VT square, BIL, again I will do mistake here, BIL. okay, so B square L square and sorry B square L square VT upon I is my R equals to mg. So this one you can solve. So VT equals to, you can get mg into R divided by B square L square. okay, so which option? mg R and V square L square, option second is your correct answer beta here. okay, so next one, so the thin convex lens of focal length 5 cm and a thin concave lens of focal length 4 cm are combined together without any gap, and this combination has magnification m1 when an object is placed 10 cm before the convex lens. So the keeping the position of the convex lens and object undisturbed, a gap of the 1 cm is introduced between the lens by moving convex lens away. okay, which leads to change in the magnification of the total lens system is m2. So the value of m2 upon m1. So first I will find, these are my two lenses, convex and concave, both are in combined. So this is my system. okay beta, and I will put one object u equals to here 10 cm away from this. So what is my combination focal length? 1 upon F equals to 1 upon my this one, first one is my convex lens is 5 cm, that is my positive, plus 1 by minus 4. So this one you can solve. So F equals to minus, you can get 20 cm. Okay, minus 20 centimeter beta. Okay, so this is the my focal length of the combined system. So position u equals to minus 10. V, what is the my magnification? M equals to V upon U. So just I am using the lens formula, 1 upon V minus 1 upon U, V1, U1 equals to 1 upon F. So what is the 1 upon U1 is my minus 10, 1 upon V1. So this one you can solve. So easily you can get V1, that is V1 is my this one minus 20 by 3. So what is the my first magnification? First magnification M1 equals to, you can get, that is my 2 by 3 minus 20 by 3 into 10. So 2 by 3. Okay, so the second condition I will solve here. Okay, in second condition this system is disturbed. Okay, and this distance is my U, and for this one is my focal length is 5 centimeter, and this is the my 4 centimeter. So first I will find what is the position of image of due to this one, that is suppose something here. So this object, this image is doing work as a object of the my lens 2 and my final length, where suppose my final image is making here. So what is this distance? Finally we need to this one. So I am just directly write the steps. Okay, so for finding this one, you can 1 upon V minus 1 upon U equals to 1 upon F. So 1 upon V minus 1 upon F. So this will be, you can get here my separation between this is the my 1 centimeter for this lens convex. So 1 upon 10 centimeter. So F is my 5 centimeter. So V1 V dash, just I will tell this one V dash. V dash you can get approximate plus 10 centimeter, means in this direction. Okay beta, so somewhere 10 centimeter is this one. So here I am just considering this is the my 10 centimeter, this distance. So what is this distance? Because the distance is between them is also 1. So what is this distance? For second condition, V 1 upon V double dash minus 1 upon U. What is the my U? Because this distance from here to here is 10 centimeter, but from this one, this is the my only 9 centimeter. So 1 upon 9 equals to 1 upon minus 4. So this one you can solve. So the second V you can get, that is minus 32 by 5, minus 36 by 5. So in both the conditions you can get magnification. So the M2 equals to, just you can write my first one, this one V upon U, and second one is multiply of this one ML2. So this ratio you can get, I will just directly write here, that is 4 by 5. And this M1 by M2 you can take, I will write here M1 by M2. So this value you can get 5 by 6. This question is challenging in the answer key. Okay beta, so this is the method. First you can find for combined, then you can go for second. Again, so the net gravitation force at the center of a square OO is found to be F1 when the 4 particles having mass m, 2m, 3m and 4m are placed at the 4 corner of the square H. So in the figure, if F2 when the position of 3m and 4m are changes to the interchange, the ratio of F1 by F2 is 1 by alpha A by root 5. So the value of A. So this is the center beta, and okay, so first I will write this one. What is the my gravitational force? F due to this one at this direction, that is my 4 gm m naught upon its distance is r, everywhere this will be fixed, and due to this one 2 gm m naught upon r, due to this one 3 gm m upon r, and this one gm m naught upon r. Here I am just considering m naught mass. So here you can see this will be only 2. So what is the my resultant that is left here? That is 2 g m m naught upon r, and this will be 4 minus 2, that is also 2 g m m naught upon r. So both are the at 90 degree beta. So what is the my resultant? Root 2 times of this one. So root 2, this is 2 is also there. So my f1 is this one and r square. Sorry beta, there is r square. Okay, in second condition the position of 2r changes. So 3m, 4m, m and 2m. Okay beta. So again similarly you can find this is the 3gm m naught upon r square. This is 4gm m naught upon r square. Okay beta, and this is 2gm m naught upon r square, and this is the cm m naught upon r square. Okay beta. So here you can again sit 3 minus 1. So this resultant of this one, okay, 3. So g m naught upon r square with this one 4 minus 3 g m naught upon r square. Again both are perpendicular beta here. So perpendicular means 3 square into 10 9, 3 square plus this square. So g m naught upon r square equals to 3 square plus 1, 3 square plus 1, 3 square is 9, 9 plus 1 is 10. So this will be 10 times upon, square root is also there into r square. This is the my f2. So beta you can take the ratio of f1 by f2. So f1 by f2, f1 is my 2 root 2 divided by root of 10. So this will be 2 upon root 5. So a equals to, you can get 2. Okay, option second is your correct answer beta here. Next one, consider a equilateral triangle or equilateral prism. Refractive index is root 2. A ray of light is incident on the surface of a certain angle I if the emergent ray is found to be graze along the other surface. Okay, so okay, so this is the condition. If the ray is found to graze along to the surface, then the angle of refraction at the incident surface is close to. Okay, so this is the my 60. So beta all of you now, what is the my r1 plus r2, that is my a. Always you can remember beta this one. So that is my r1 r2. So the refractive index of the surface is close to, okay, refractive index they will, so the incident surface is close to refraction. Okay, so what is the my just you can apply Snell's law, mu sin I equals to, outside this one, inside this one, 1 air is 1 sin E is my 90 degree here. So mu sin I equals to mu sin R2, R2. Okay, so R2 is this one and R1 is this one, because R1 plus R2 equals to A. Okay, so mu sin I equals to 1 and mu of refractive index of this one is root 2. So sin R2 equals to 1 by root 2. So R2 equals to, you can get 45 degree. So R2 value you can put here. So 45 plus R1 equals to 60 degree. So R1 is my 15 degree beta. Okay, so option third is your correct answer beta. Okay, so we will move for next one. A simple pendulum has bob with the mass m and charge q. The pendulum string has negligible mass. When a uniform horizontal electric field E is applied, the tension in the string change. Okay, so the field tension in the string when pendulum attains a equilibrium position. Okay, so beta this is the my original, and if I am applying the electric field in this direction E, and tension in the string is this one, and it will be at angle theta, and down one direction is my mg. So this is the my QE, F equals to Q electric field, force on due to the my electric field. Okay, so what is the resultant of this one? Both are at 90 degree. That is my square root of I am just writing here square root of QE square plus mg square. So this will be equals to my tension force. So T equals to QE square upon mg square. So m square, g square, q square. Option first one is your question. So this is the direct question from our regular practice sessions. Okay, beta. Next one. So the electric field is a region given by this one, where A is this one volt and B is this one. If the electric potential at point is this one, then so the electric potential at its origin. So beta, all of you now, what is the my relation between electric potential V and E equals to minus del V upon R. So delta V equals to minus E dot dr. Okay, E vector is given and at certain points V at 20 equals to that much 500 volt. Okay, beta. So delta V is 500 minus V naught equals to minus E dot dr. E is my A x I k plus B y j k into dx I k plus dy j k. Okay, so just you can do this integration from origin to 20, 10, 20. Okay. Okay, again you can do here integrate and then you can put value, that every time you can get same. So do this integration, A into x square by 2 plus B into y square by 2 and its value is 0, 0, 2, 10, comma 20. So just you can put the value here. So V naught you can easily get here. V naught equals to 500 plus A is my 10. 10 into x point is my 10. 10 is 100 square divided by 2 plus, okay, B is my 5 into y is 20 into 400 divided by 2. Okay, so just you can solve this one. So V equals to, you can, V naught equals to, you can get 2000. Okay, beta. So nothing is there. Next one, find the correct combination of A, B, C, D input which can cause the LED is glow. So in which condition beta my LED is glow? When my diode is in forward bias. Forward bias means this point is my at higher potential, P point at higher potential, P and Q. So P is at higher and this will be my at low potential. Okay, so how we can find what is the my potential? So just you can catch up one options and you can put here. So first one, I will check first option. So 0, 0, 0, 0 plus 0 is 0, 0 bar is 1 and 0, 0 because again NOR gate. So 1, 1, 1 is coming here, 1 multiply 1 is 1, 1 bar of this one is 0. So this is the low potential. So option 1 is my wrong. Similarly, you can put option 2, 1 and 0. So 1 you can get here. So here is 0 and here you can get 1. So 1 comma 0, 0, 0 bar is 1. Okay, somewhere I will do mistake, 1 and 0 AB, 1 and 0. So 1 bar is 0 and 0 is coming here 1. 1 into 0 is 0, 0 bar is 1. Okay, beta. And second condition, this will be 1. So C and D you can put 0 comma 0, 0, 0, 0 plus 0 is 0 and 1. So both are the in same potential, again not working. So this is also wrong. Similarly, you can check third one. So 1, 1, 1, 1. So 1 plus 1 is 1, 1 bar is 0. 1 plus 1 is 1 and 1 bar is again 0. 0, 0 into 0, 0 bar 1 is 1. Again you can put 0 into 1 of this one. So again both you can get the same 1, 1. So again same potential, but you can check similarly option 4. So this will be you can get 1 and this will you can get 0. So this is the my high potential and this is the my low potential. This is the forward bias. So my LED is glow here. Okay, so option 4th is your correct answer beta here. Next one, a cylindrical tube AB of length L closed at the both ends contains an ideal gas of 1 mole. Okay, having 1 mole, N equals to 1 mole, having the molecular weight of M. The tube is rotated in a horizontal plane with constant angular velocity omega about an axis perpendicular to AB. Okay, so the passing through the edge of the A as shown in the figure. So if PA and PB are the pressure A and B respectively, then consider the temperature of same at all points, the tubes. So beta, nothing you can do, just you can take the small component of this one, okay, and just consider that side pressure is P. A small element you can consider as a dx, okay beta, and it is rotating, so my centripetal force is working in this, A equals to omega square into x, okay. And this component I am trying to explain here. If my pressure, this distance is x, in this side I am just considering its pressure is P. So what is the pressure in this side? P plus delta P, okay beta. So what is the my pressure in both the sides? That is P into delta P. So beta, just force P equals to F upon A, and A equals to F equals to my pressure into area, and F equals to M into A equals to, and this small element I will just consider mass of the small element, that is my delta M, okay beta. So P equals to P into A, so I am just writing here beta, delta M. A is my omega square x, and the pressure into area, so pressure at this point and at that point, so just you can write A into P plus delta P into minus P, pressure difference there, so delta M into omega square x equals to, P to P is cancel out, del dP into area of this one is A, okay beta, nothing is there. So delta P equals to, and delta M equals to, you can also put rho equals to M upon V, V equals to M equals to rho into V, volume is area into its height, okay beta. So just you can put area of height, this one, so delta P, I am just writing delta P here equals to rho is constant, area is constant, x is changeable, so rho A dx into omega square x divided by A, okay beta. This is the my pressure. So all of now PV equals to n RT, so V is the my volume, rho equals to M upon V, so V equals to M upon V, so PM equals to rho into RT. So rho, this rho value you can find here, rho equals to PM upon RT. So this rho value you can put here, PM divided by RT into omega square x dx. Just you can do the integrate both sides, so delta P upon P equals to M upon RT, RT into omega square x dx, 0 to L, 0 to L and PA to PB. So this integration is, I am writing similarly here, ln PB upon PA, and this integration value is x square by 2 and 0 to L, so omega square L square M upon omega square L square upon RT R into T. So just if I am removing this log, so PB equals to exponential of this one, omega square L square upon RT, okay. So beta, there is M is also, I forgot that one, okay. So PB equals to P upon PA, so P, pressure at A is my P, okay. So my final answer equals to PB equals to PA into exponential M omega square L square upon 2 RT. Beta, there is my 2 factor is also coming, because what is the integration of x? X square by 2, so there is the my 2 factor is also there. So option 1 is your correct answer. Next question. So the two loudspeaker L1 and L2 are placed with the separation of 10 meter. So the separation between is 10 as shown in the figure. So the both speakers are fed with an audio input signal of the same frequency with constant volume. A voice recorder initially at point A and equidistance both the loudspeaker is signal was found to be using 10 cycle of the maximum and minimum during the movement. Okay, when these are the movement, so the maximum and minimum 10 cycles of the maximum and minimum during the movement. So the frequency of input signal is in hertz. So the speed of sound in air, that is this one, and square root of 5, that value is also provided here. Okay beta, so just similarly nothing is there, speaker is given, so just you can find the what is the my path difference between, then both they are reaching at the point B. Okay, if this one is this, so what is this distance beta? This distance is my 20, and this distance from here to up to here, that is my 30. So first you can find what is the my path difference of this one. This question is mix up with my wave and the wave optics and the my sound waves. Okay, so here just you can see at the origin there is, when it is doing 10 cycles in during the movement, so there is the my maximum, minimum, maximum. So at 10th cycle it will be at the point B. At that point it will be in the my 10th maxima. Okay beta, so there is the 10th maxima. So just you can find what is the my path difference delta x. Okay, just for finding the path difference, that is L2B minus L1B. So how to we can find L2B and L1B? So just you can make one triangle and you can easily get this one. Okay beta, so this is my 40, this is my 30, so L2B square root of this one, 40 square and 30 square, and L1 B equals to 20 square plus 40 square. Okay beta, okay, so this calculation you can done, that time you can get 40 plus 30, that is my 50, and this value you can 40 square plus 20, 1600, and 400, 2000. So this value you can get approximate to 20, this value is 20 root 5. Okay, so just you can take the difference of this one. So delta x equals to, you can get L2B. L2B is my 50 minus 20 into 1.14. So this delta x equals to, you can get how much? That is the my 5.4. So delta x is the my n lambda 5.4. So n is my 10. So wavelength equals to 5.4 divided by 10. So my lambda equals to, you can get how much? This one. So all of now V equals to f lambda. Okay, f lambda. So V equals to frequency they will ask. So f equals to V upon wavelength lambda. So V is my 3324 is 5.4 divided by 10. So this calculation you can do. So you can get what is the my frequency of this one, that is my 600. Okay, so the final answer of this one is my 600 beta. Next one. So the circular disc has radius r1 and a thickness t1. Another circular disc made of the same material has the radius r2 and thickness t2. If the momentum of inertia both the have same one, so I1 equals to I2. This information is given in the question. So R1 by R2 is given, so they will ask what is the T1 by T2 equals to 1 upon alpha, then the value of alpha. These are the two rings, its radius R1 and thickness T1, T2. Okay, so what is the my mass of this one? Density into volume. So density of this one rho and pi r square into T. And similarly mass of second one m2 equals to pi r2 square, volume into its density, same material. Okay, another circular made of the same material, so rho. Okay, so what is the my momentum of inertia both they have? So mr square beta, I equals to mr square by 2. So just you can, these values you can put here, so you can get relation between my t and r. Okay beta, so here both are equal, so 2 to 2 is cancel out and rho to rho is cancel out, pi to pi is cancel. So r1 square t1 equals to r2 square t2. So T1 by T2 they will ask. T1 by T2 equals to R2 by R1 whole square. So R1 by R2 equals to 2, so 1 by 2. So 1 by 2 equals to 1 by 4. Okay. Somewhere I will do, just recheck I will this one. Okay, so my both the momentum of inertia I1 equals to mr square 2 to 2 is cancel out, and m1 equals to pi r1 t1 density is also cancel out. Oh sorry, there is the my r1 is also there, so r power 4 is there beta. Okay, so r power 4 means that is the my 16. Okay, that is the r power 4, r power 4 and r power 4. So t1 by t2 you can get 1 upon 60. So alpha value is my 16. So the inductance of a coil is 10 to the power 4 turns is 10 millihenry, and it is connected to a DC source of 10 volt with the internal resistance is this one. So the energy density in the inductor when the current reached by 1 upon E of its maximum value is alpha pi into 1 upon E square joule per meter cube. So the value of alpha, but nothing is there. So what is the my 10 volt battery and its internal resistance is 10. So I max is 10 divided by 10, that is my 1 ampere. So the energy density in the inductor when the current is 1 upon E. So 1 upon E square means I is my 1 upon E. So the my energy density AD equals to what is the my energy density formula, that is mu naught n square I by 2. Okay beta, so mu naught equals to 4 pi into 10 to the power minus 7, and number of turns per length with this 10 turn is 10 to the power 4 connected to DC1. So n square is 10 to the power 4 whole square divided by current is 1 upon E. Okay beta, I is also square my 1 upon E square, then n square I square. Okay beta, so and divided by 2. So this value you can solve, then you can get 20 pi. Okay, so this value you can get 20 pi into 1 upon E square. So what is my final answer? That is my 20. Okay beta. Next one, 3 electric field of a plane electromagnetic wave traveling in an unknown non-magnetic medium is given by Ey equals to 20 sine 3 into 10 to the power 6x minus 4.5 10 to the power 14 t volt per meter. So x and t are other value have the SI unit. So the dielectric constant of the medium epsilon r they will ask beta. Okay, light of free space in this one 3 into 10 to the power 8. Okay, so just you can compare, this one is the my standard equation, wave equation. So Ey equals to a sine omega t plus minus kx. Kx. So what is the my omega value? Omega is 4.5 into 10 to the power 14, and my k is 3 into 10 to the power 6. So what is the my wave speed? V equals to omega upon k. Omega upon k. So omega is 4.5 into 10 to the power 14 divided by 3. 4. Divided by 3 into 10 to the power 6. So this calculation you can done, that time you can get 1.5 into 10 to the power 8 meter per second, 10 to the power 8. Okay, so the speed of the electromagnetic wave in non-magnetic medium, that is my c upon mu. Speed of this one V equals to c upon mu r into epsilon r. So epsilon, so the dielectric constant of the medium epsilon r they will ask. So V is this one, so c and mu r for the free space equals to 1. So 3 into 10 to the power 8 divided by V, speed of this one 1.5 into 10 to the power 8. So this will be cancel out 2 times, so epsilon r equals to, you can get 4. Okay, so the 4 is my final answer. So the parallel beam of light traveling in air, refractive index is 1.0, is the incident on a convex spherical glass surface of the radius of curvature is 50 centimeter. Refractive index of the glass is 1.5. The ray converging to the point a distance x from the center of the curvature of the spherical surface. So the value of x. Okay beta. So and it is from infinite. So the refractive index of this one is 1.5 and it is my 1. So beta, just you can use the formula of lens maker. Okay, so mu2 upon u equals to mu2 minus mu1 upon r. So it is coming from infinite. So mu2 is 1.5 divided by v equals to 1 upon r. Okay beta, so that is my 50. 1.5 minus 1 divided by 50, so v value you can get equals to 150. Okay, so where they will ask this distance, refractive index is this one, so the ray converges to a point at distance x from the center of the curvature. So from here to here, this distance, so this distance they will ask, so 50 minus 150 minus 50, that is my 100 beta. So the value of x is my 100 centimeter. Okay, so this is the complete paper discussion. So thank you beta for joining the session. Okay, bye. So we will meet in next session. Okay, bye beta.